So I'm just extremely disappointed in those quiz grades.
Well, in some, right?
I'm extremely disappointed overall in the overall average of the quiz grades. There were some who did well, yes, but it should have been an easy grade for us all because, again, I never said Ms. Brister must calculate the axis of symmetry by hand. I said, hey, you can do it by hand, or here's how you figure it out with a calculator. And I went over that and over that and over that. And if you didn't understand something, then why was my room so empty this morning during zero period? Or why did you not rewatch the video on Google Classroom? Why are you not doing anything to help your own grade? I'm not your mommy. And although I love you, I cannot fix it for you. So you've got to, my mom bought me this last Christmas. And I always loved it. She said, I can explain it to you, but I can't understand it for you. So literally the truth. I've explained it and explained it and explained it. The understanding part's on you. And when you choose to lay your head down in math class, it's no wonder you're going to probably not do well this semester. It is what it is. Okay. I'm going to get off my soapbox and do math because I do love math. That's the good thing about math. It can't let you down. It stays the same. Oh, goodness. I need help with 6 through 10. And then we're going to get through some notes today. And if you want to preemptively move your group to a 5, as long as you're not slowing me down, you can put your group at a 5, and we can just do bonus from here. Everyone could use a little bonus. Okay, what's the GCF that I can pull out? Seth, you said GCF first. You can have the point. We'd be left with Q squared minus 3Q plus 12. Okay, thank you. Okay, is that all I can do? Am I done? Yes. 3PQ is done, but can't I factor the P squared minus 3Q plus 12? So I need two things that multiply to give me 12, add to give me negative 3. I might be done. I don't know. I've got to think of 3. So we could do 1 and 12. We could do 2 and 6. We could do 3 and 4. Do any of those have a difference of 3? No. So we literally actually were done. Grouping is for number 7. Everyone can get another point. In that first group, I'm going to pull out an x, and I'm left with x plus 4. In the second group, I pull out a 2. I'm also left with x plus 4. So my answer is x plus 2, x plus 4. I can tell you something I already know, because for once in our life we planned it out. The math workshop test is the Monday of Thanksgiving week. So if you're going to be gone all Thanksgiving week because you decided you're taking Monday and Tuesday off, that's fine. We'll do you the Friday before Thanksgiving week. Okay, number 8 is a pretty factoring because it's got that leading coefficient of 1. I need two things that multiply to give me 12 and add to give me 7. Yes, table 6, you can have the point. Negative 3, negative 4 give me negative 7. Negative 3 times negative 4 gives me positive 12. That's perfect. Number 9. It is a perfect square. It is going to be 4 minus w squared and 4 plus w squared. And I'll give you that, and what stinks is we can break it down more than that. Yeah, because 4, the perfect square of 4 is 2, so it's really 2 plus w, 2 minus w, for that first set of parentheses. So this parenthesis breaks down into 2 plus w, 2 minus w. And then this one I want to break down, and I just can't do it well, can I? Because it's a plus, not a minus. That's actually an interesting thing, because if I know you just learned your perfect cubes, and no, we don't. I don't think we have a test where you have to learn stuff to the 4th power, but it just so happens that 2 to the 4th power is 16. So there was probably more we could have done to begin with. We just don't know all that kind of jazz yet. Okay, our most difficult factoring of the day is written on top of it. It says 2n squared plus 3n minus 9. Today is the day to do a good job guessing and checking. So I know it's a 2N, I know it's an N. What should I guess for my other numbers?
Can't you put 30 in on it? That's what I just said.
Okay, let's see. So if I do negative 3 cos 3 and I FOIL it out, I'd have 2N squared plus 6N minus 3N minus 9. So when I combine my like terms, 2N squared plus 3N minus 9, hey, that is what I had to begin with, so you guessed and checked correctly. You guessed and checked correctly. You can have a point. Yes, dear. Do what, dear? It's right. At the end of class, I'll time you on it. Just put it to the side for me. Okay, are there any questions about this? We're going to discuss another way today. I originally said we were going to discuss lots of ways, but to be honest with you, somehow we're still really, really behind the other regular classes. So we're going to have to keep our factoring pretty short and sweet. Go to page 13 in your notes. Okay, so we learned how to graph a quadratic function. We learned how to look for the 6 things: the axis of symmetry, the vertex, min, max, domain, range, y-intercept. We even learned about x-intercepts and how important they were. And now we're going to learn how to make some stuff happen by hand. Those x-intercepts you were calculating with your calculator and setting bounds and stuff, we can actually find those through factoring, and that's what we're going to do today. So we can find those x-intercepts, roots, and zeros by factoring. And I might even write that. We can find... Thank you, dear. We can find x-intercepts by factoring. Now, again, I've not taken that calculator away from you. I've just said we don't need it today. So could Mia always check herself since she knows how to find the zeros with her graphing calculator? Yes, she could. Okay, and since we're in a hurry, there are some of these we're going to skip because they're not quadratic functions. So I'm going to skip a lot of these problems. I'm going to do, let's see, I'm not going to do number 1, even though it's grouping, because there's nobody to the second power. I'm not going to do number 3, because it's to the 4th, 5, because it's to the 3rd, or 4, because it's to the 3rd. So any problem that's not literally to the second power, because we're on quadratics, we're going to skip. Originally, when they made these notes, they hadn't been practicing factoring in their math workshops the way we have been, so it's really not necessary. So the only one we're doing in the top 5 is number 2. What am I supposed to do on number 2? Does it? What's the GCF? What can I pull out of all 3 terms? If I pull out that 3, thank you, table 3, I'm left with a z squared, you can have a point for it, plus 8z plus 15. I'm going to leave that 3 on the outside. Can I break down that z squared plus 8 plus 15? What would it be? I need 2 things that multiply to give me 15, add to give me 8.
3, 5, and 3.
1, 3, and 6 get a point. Okay, so all we have to do on the top 5 is factor. That's it. So we're done here. Now the bottom 6 is where life gets a little interesting because we actually are going to solve. 1, because the directions say to solve, and 2, because they differ since it has that equals 0. Equals 0. Okay, so we're going to do most of the ones on the bottom. So let's look at number 6. What can I do on number 6? What is my GCF on number 6? 5 what? Okay, thank you, table 4. You said it first, so you can have the point. So it's 5x, so I'm left with 4x plus 3. And this is all equals 0. So I know normally we would be done, but since it has that equals 0 and the directions say solve, we literally need to solve. No, we're not going to redistribute. What we're actually going to do is, again, if it's a quadratic, which it is because it's to the second power, it could potentially have 2 answers. So now we're going to deal with our 2 different, it doesn't have to have 2 answers, but it could have up to 2 answers. We're actually going to take each of these terms and set them equal to 0. So 5x equals 0, and 4x plus 3 equals 0. So I set this equal to 0, and this equal to 0. Because regardless, since I'm multiplying, as long as one of them's 0, the whole thing's going to end up being 0. Okay, so I solve this equation, and I get x equals what? I solve this one, and I get x equals what? The first one's 0, and the second one is negative 3/4. Thank you, table 6. You can have your point.
Or else it's going to be negative points.
Yeah, but I like fractions. We're going to leave it as fractions. Okay, and then I skipped something really important, which was our top learning target, which I think we all need to do anyway, which is what's going to happen on number 7. It has to be in standard form. Is number 7 in standard form? No, so we have to rearrange number 7 before we play this game. So I subtract 60, table 1, get a point. I can subtract 64 from both sides. I have x squared minus 64 equals 0. If you don't have everything equals 0, you're not in standard form. You can't factor. Okay, when I factor this, what do I get? Because it's the difference of perfect squares. Table 1 gets the point. Okay, so I'm going to set each of these equal to 0. So I'm going to do x minus 8 equals 0 and x plus 8 equals 0. So I have 2 answers. What are my 2 answers?
X equals 8 and x equals negative 8.
Perfect, Arturo, and you can have a point. Okay, but if you're trying to be fancy and mathematical, you know you could easily write that as x equals plus or minus 8. So if you don't want to write 2 different answers, plus or minus 8 indicates you have those 2 different answers. Okay, are there any questions about number 7? Either. If you get there, I'm happy. You know that. Okay, we're going to skip number 8 for the moment. We're going to go to number 9. When I rearrange number 9 and put it in standard form, how would that read? Day, do you mind if I give 5 the point? 5, you can have the point. Okay, so I'm needing 2 things that multiply to negative 21 and 2 things that add to negative 4.
3 and 7.
Are they both negative? Are they both positive? Tell me a little more.
Both are, one's positive and one's negative.
Okay, but which one?
X plus 7 and x minus 3.
I think it's the other way around because negative 7 plus 3 is negative 4. So I think it has to be the other way around. Negative 7 plus 3 is negative 4. Negative 7 times 3 is negative 21. But we'll give you the point. And so when I set each of those equal to 0, I get 2 answers. What are my 2 answers?
Positive 7 and negative 3.
Table 1. Okay. So now we've left 8, 10, and 11 empty. Why have I saved those 3?
That's for us to do homework.
No, they're not. No, we're going to do them now. That's a good question. They would be terrible for you to do as homework because what's that leading coefficient on all 3?
1.
Not 1. Anything but 1. So I'm going to go ahead and fix number 10. It needs to be 15x squared minus 8x plus 1 equals 0. But from here, we've got to talk about how to factor. Okay, if you like my guess and check, my guess and check works. If you don't like my guess and check, today is the day you get your second option. So I'm going to do first with guess and check. So if you like guess and check, now let's guess and check. So I'm guessing that it's supposed to be, so it's 4x squared. So I could do 4 and 1, or I could do 2 and 2. Which one do you want to guess? It's a good guess. Might as well try it. If we're wrong, we might want to change that to 4x and 1x. We're just guessing. Literally guess and check. Okay, we need numbers that multiply to 9. So am I going to do 1 and 9 or 3 and 3? Okay, you want to do 3 and 3. Should I do a plus or a minus?
Just do minus.
On both or only on one?
Only one.
If I have to do it on both, that way it doesn't mean that positive 9 at the end. Okay, so we guessed. We might or may not be wrong, right or wrong. We're going to FOIL it out and check. First is 4x squared, minus 6x for the outer, minus 6x for the inner, plus 9 equals 0. Lo and behold, you guessed correctly, because when we combine those middle terms, we do get 4x squared minus 12x plus 9. So if you understood how to guess this, that's terrific. If you don't understand how to guess that, here is my suggestion to you. Miss Brister loves grouping. She loves it. She thinks it's the greatest. So she's trying to make grouping happen. So she wants to make two groups that she's going to deal with. I don't know why I put that extra parenthesis. She's going to figure out how to bust up that middle negative 12x in order to put part of negative 12 with this group and part of it with this group. For instance, maybe she says, well, I already can tell in the first group I'm wanting to factor out a 4. And I know 4, so 4 times 8, that goes. So maybe I'll put the 8x here and the 4x here. I have to think through my thoughts. Isn't that what you're doing, Miss Brister? You do bottoms up. You don't bust them up. Okay. Okay, so let me show you what Miss Brister does instead. Again, I'm a guessing checker. That's me. Do I know 1,000 other ways to do it, which is bust them up, and then she does bottoms up, which I like, and she's going to teach her people, so I'll show you the way she teaches her people, and if you like it and you want to ask her questions, she's more of an expert on it than me. Yeah, she does bottoms up, which is where you do slide, meaning you take that first term and you send it down to the end. So x squared minus 12x plus 36 equals 0. That's her slide step. And the reason she does this is now she's created it where it's a nice problem with a leading coefficient of 1. So she's just having to factor this easy thing, which leads to her next step, which is divide. So she knows it's supposed to be something that adds to 36 and subtracts to negative 12. So 6 and 6 would work. So x minus 6, that adds to negative 12, that multiplies 36, that works. You can have one. And then bottoms up is the step that most people forget, which is why I normally don't do this way. But if you'll remember it, this is the easier way. Bottoms up literally means she's got to do something about that 4. That 4 didn't go away. And if she FOILs out what she has now, she's going to get this instead of her original. So the bottoms up, she ends up putting that 4 under each of her factors. But you and I both know 6 over 4 reduces to 3 over 2. And doesn't nobody wants the fraction thing going on. So she actually moves that 2 to the front. So the 2 in the denominator she puts in front of the x. So she does slide, where she slides that first thing down. Divide, where she ends up factoring with a leading coefficient of 1. And then, for the part that most people forget, including me, so I don't get to do this, bottoms up, where I end up simplifying my fraction. And I don't want that in the denominator, so I put it in front of the 2. And as you recall, our answer was also 2x minus 3, 2x minus 3. So it's a different way, but it always works. Yes, dear? What happened to, I forgot to leave the equal 0. Thank you, dear. You have no point for that. Okay, So I'm going to do another one like that in a second, but seriously, I'm more of a guessing checker. I am. I mean, I got my calculator. I'm pretty good at figuring out what multiplies to what. Guessing and checking has yet to let me down. Whereas bottoms up, you got to remember there are 3 steps. So it's really up to you. Okay, but I wasn't done with either of them. Because I circled it like that was the answer. And I don't have x equals nothing. I actually need to solve, so I need to do 2x minus 3 equals 0, and 2x minus 3 equals 0. And what do I get as my answer? I know it happened twice. We'll talk about it in a second. What do I get as my answer? You can have a point one. Okay, so we've been talking about graphing quadratics. And we talked about that these answers we're coming up with are where these x-intercepts occur. So like on our previous example, on number 6, for instance, our 2 zeros were at 0 and negative 3 over 4. So our parabola crosses the x-axis at those 2 points. Well, in this one, our parabola crosses the x-axis at 3 over 2 and only at 3 over 2. So it just means it hit it only once. It's okay to only have one and it happened twice. That's fine. It doesn't have to have 2 different answers. It can only have up to 2 answers. So it might have no answers, 1 answer, or 2 answers. No answers would be like those that never actually cross the x-axis at all.
Would you say root instead of root?
Yes. Yes. Okay, let's go to number 10. So I see number 10 is 15x squared minus 8x plus 1. And we'll do both mine and Miss Brister's way. I moved it to standard form. I'm trying to think through what multiplies to 15. So I can either do 1 and 15 or I can do 3 and 5. Which one do y'all want to try? Okay, so if we try 3x and 5x, I need the end term to multiply to 1. What multiplies to 1? We know it's 1, but is it both positive ones or both negative ones? They both have to be negative because that middle term. So we FOIL it out and check. It's 15x squared minus 3x minus 5x plus 1. Lo and behold, that middle does end up being that negative 8x. So we guessed correctly. This was correct. Now we're going to have to solve in a second. And let's go ahead and solve. I get x equals what number and x equals whatever number. What are my 2 answers?
X equals 1 over 3 and x equals 1 over 5.
You can have a pointer, sure. Point, get it together. Okay, so 3x minus 1 equals 0, so x equals 1/3. 5x minus 1 equals 0, so x equals 1/5. If you're starting to do this in your head, that doesn't bother me. I do it in my head as well. Okay, but if you're hating this and you do not like this guess and check and you just cannot do it, we will also do Miss Brister's way. And if you're still not liking those ways, if you'll come see me, I swear I've got at least 2 more ways up my sleeve I can try to make you like factoring. Okay, so let's see. It was 15x squared minus 8x plus 1 equals 0. So her first step, she slides. So it would be x squared minus 8x plus 15 equals 0. She divides. She's trying to figure out things that add to negative 8 and multiply to 15, and she's going to pick negative 3 and negative 5. And then bottoms up, she's going to put x minus 3 over 15 over that first term, and x minus 5 over 15. She says, hey, those fractions, ooh, that's hard to see. She says, hey, those fractions reduce to x minus 1/5 and x minus 1/3. So she finally writes her answer as 5x minus 1, 3x minus 1, and lo and behold, Miss Brister got the exact same factors you and I got using a different method. So pick the method you like and roll with it. Okay, I'm going to let y'all try number 11, and then we'll go over the answer.
Don't let me do this.
Ooh, there's a GCF. You better pull that bad boy out first.
You didn't give me even more.
Ooh, it ends up being easy. You got this. Yes, dear. Did you pull out your GCF? What was your GCF on 11? What goes into all three terms? What number divides into all three terms? Then pull out a 2. When you pull out a 2, what are you left with remaining? So once you pull out a 2, weren't you left with the x squared minus 6x plus 8? Stay talking about it.
Don't you pull it? Like pull it out?
Someone got some answers for me.
They already said. You try to get a receipt.
You don't have to do bottoms up with this one though, because once you pull out a 2, it ends up being an easy factor on your F. Yes, Eduardo. Yeah, ignore the 2 outside and just do the 2 terms equal to 0. So what would the 2 answers be? Yes. Okay, so let's talk about it. So 6 point. Okay, so let's talk about it. I actually gave you an easy one. We pull out a 2. When you're on my nerves. We pull out a 2. 2 divides into 2 one time, so we're left with 1x squared. Negative 12 divided by 2 is negative 6. 16 divided by 2 is 8. So we have x squared minus 8x minus 6x plus 8. That's an easy factor. I'm thinking of 2 things that add to negative 6, multiply to positive 8, so I get negative 4 and 2. And then as for my 2 answers, I know the 2 on the outside bothers you, but if we were solving this equation and we divided both sides by 2, 0 divided by 2 is still 0. So any constants you get, if you want to just, like, you pulled out, you really can just ignore them because it ends up being the parenthesis thing equal to 0, the other parenthesis thing equal to 0. But here's why you ignore them, because if I divided both sides by that constant, 0 divided by 2 is really just 0. Okay, are there any questions about this? It's really taking what you've been doing for a while with me, factoring, and now applying it to what we just tested on with quadratics. So what we're finding are those 2x intercepts, or up to 2x intercepts, what I should say. Okay, are there any major questions about this before I blow your mind? Okay. But what are we going to do when we can't factor? Not like you and I are incompetent can't factor. What do we do when the thing is not factorable? Then what? But what if it might still have answers? We just couldn't find those answers with factoring. So we couldn't find them. We tried grouping, we tried GCF, we tried everything. It wouldn't work. So we've got to have a reason as to why that happens, and it involves the quadratic formula. And before we're ready to tackle on the quadratic formula, the last topic we have to talk about before our next test is getting us ready for the quadratic formula, which is what we go to when life won't factor. And in order to use that quadratic formula effectively, we need to talk about something called complex numbers. At the beginning of the year, we talked about different number systems, and I made you take a test, and I'm with you, and it seems silly, and like natural and whole and integer and real, and so we've not actually spent time on imaginary. We joked that there were these numbers that were called imaginary, and this is your first real exposure to them. Now, imaginary numbers are terrific. However, your calculator cannot help you do any of these. Your calculator doesn't have a button to help you with things like this. Okay, so you know, Alonda, you're on my nerves. You know the square root of 25 is 5. The issue is we don't know what the square root of negative 25 is. We don't know that. So that's where imaginary numbers come in. If there's a negative under your square root, we can actually bust up our the number underneath our radical into negative 1 times 25. And if we do that, hey, I don't know that square root of negative 1, but hey, I do know the square root of 25. It's 5. Well, they noticed this kept happening a lot, so they started to decide that they were going to have a number to a letter of the alphabet to represent that square root of negative 1. So anytime you see the square root of negative 1, you can put the letter I, because I is equal to the square root of negative 1. So literally in my answer, I'm going to have I, because every time I see square root of negative 1, I replace it with I. And the square root of 25 is 5. So my final answer would be, sorry, I'm going up instead of down, 5i. So I replaced that square root of negative 1 with the letter I, and 5 times I just wrote it as 5i. So all we're doing is trying to deal with those negative numbers under the square root. And in order to do so, we have to involve something called imaginary numbers. And the important part is I is the square root of negative 1. Yes, dear?
So if it's a negative number, we get the same answer, but we just put I at the end of it. So that way
It's going to end up being that way, yeah. A lot of the time it's going to end up being that way. Okay, it's a little more complicated than I'm making it sound. Let's go ahead and do 1, 2, and 3, and then we'll deal with 4 and 5. Well, I know it's going to be 11i. So again, I'm busting it up into negative 1 times 121. And if you want to spread them out again, you can. So it's negative square root of 1, negative and square root of 121. So it ends up being I times 11, which is 11i. So it does end up being the perfect square number with the letter I every time, yes. No, because y'all are so chatty. Okay, number 2, y'all want to go ahead and tell me the answer on number 2 then. 196 is a perfect square, you're supposed to know. So it's going to be 14i. But it's because we're going to do 196 and square root of negative 1. So that's why it ends up being 14i, yes. 3, you can have the point. Yes, you can have the point 1. I don't know, y'all are super chatty. You can have it, but yes. Okay, so none of those perfect squares suddenly come in handy. So on the next one, I could rewrite this as negative 1 times 2. So I could really say this is square root of 2i. Is everyone good with square root of negative 2 being square root of 2i? So my next one, yes, it was negative 1 times 32, but I know the square root of negative 1 is just I, so it's really square root of 32i. So when I put them together and I multiply them, I end up taking the numbers on the outside and putting them together under the house, and the i's together and I put them on the outside. And i's work just like x's would work, so if this was x times x, you would tell me it was x squared, so it's going to end up being I squared, yes. Okay, so 2 times 32 is 64, so I'm going to have square root of 64 I squared. And here's the part where you would like for me to tell you some words of wisdom, which is going to come to me. So I don't know if you want to make this list at the top. So the cool thing about I squared is that it always ends up being negative 1. So yes, I is the square root of negative 1, but I squared is square root of negative 1 times square root of negative, it ends up being negative 1. And then I to the third ends up being, they did this 3 times, so it ends up being negative square root of negative 1, so it ends up being like negative I. It's terribly annoying. And the only one that ends up being nice is I to the 4th. And the reason I to the 4th is nice is because I squared was -1. So I to the 4th is really I squared times I squared. So it's really -1 times -1, which is darn positive 1. So if you get I to the 4th, you got darn positive 1. Yes, dear. Yes, dear. Yes, we gotta keep going, yes. But I had to use my little intervention to say something about I squared. It's an I. Okay, so I've got square root of -1 for I. I squared ends up being just -1. And I to the 4th ends up being positive 1. If you want to memorize I to the 3rd, you can. But seriously, I just know I squared is -1. And I to the 4th is positive 1. And here's why. But once you know why, you just roll with it. Okay, so back to our problem. Yes, dear. Yes, it's I to the 2nd, but just change the sign. Yeah. Yes. Which, that's the same relationship between I and I to the 3rd. It's just with an extra negative on the outside. Okay, so let's go back to the problem we were dealing with. Yes, you're right. I know the square root of 64 is 8. But I also know that I squared is -1. So my answer ends up being -8. Because it's I squared. Okay, so on the next one, if I write this as 75I times square root of 3I, I get square root of something I squared. I need to know what that something is, and I swear I'll stop talking. 75 times 3.
225.
That's a point, right?
Okay, and I know the square root of 225. Yes, Tyreek. And what's the square root of 225?
Oh, 5, no.
Thank you, Hunter. So it's -15.
Dang.
Okay, so I will, my video tomorrow will have to start for you on number 6. I'm going to go through all of them from here on out. I'm sorry, but the complex numbers is something you're going to have to watch me a video. If you're super confused, you're going to have to come see me. I'm not psychic. I do not know.